Hello guys, this is um, the second day of review, and so this is up here on the YouTube channel just for reference, or also if you missed today, okay, a lot of you are missing today, please look at this so that you can answer some of these review questions. I'm going to go ahead and indicate over here what questions these are kind of like, and so this is where we left off on the first day. And these questions right here that I'm about to go over, this is like questions number 19 and number 20 on your review sheet. Okay, so here they're asking us to find the the rectangular form of the polar equation. So like last time, where we left off on, the equation I want to use, the relationship I want to use, is this one right here. Tangent theta equals y over x. So what I want to do, I have the theta here. The theta is pi over 3. So I want to go to a unit circle and look at pi over 3. So I'm going to do that. I have one right here. So here's pi over 3. This is my x. And this is my y. So it's 1/2 and square root of 3 over 2. So that's where I'm getting these numbers that I'm about to write. At 1/2 and square root of 3 over 2. So what I want to do is divide y and x. Okay, so square root of 3 over 2 divided by 1/2. And that's what's going to equal y over x. So here I'm going to do keep, flip, and change. So this is going to be square root of 3 over 2 times 2 over 1. So these will cancel. This is going to equal square root of 3 over 1, which is just the square root of 3. Okay, and this is what equals y over x. Remember, we're making an equation, so that's why I'm keeping the y over x. Now I do want the y by itself, so I'll multiply by x here, so they cancel. Put it over here. So y is equal to x square root of 3. And that's my answer. This equation. Now, one thing I want you to notice here is that this is a linear equation. It says y equals something to the x with a 1 power. There's no squares here, so it's not y squared, it's not x squared. So keep that in mind, guys. This problem shouldn't be one that you struggle with, but just keep in mind that it's also linear. So y equals something, okay? Not y squared equals something, not y equals x squared, y is equal to x, okay? So, another example here. Use the same equation. Okay, but now I want to use 3 pi over 4. So at 3 pi over 4 right here, my x and y is this right here. So, at 3 pi over 4, my coordinate is square root of 2 over 2, negative, and square root of 2 over 2. And again, I want to divide the y by the x. So square root of 2 over 2 divided by negative square root of 2 over 2 equals y over x. So this will equal negative 1. And again, I want the y by itself, so multiplied by x. Multiplied by x. So this equals y equals negative x. Okay. So, excuse me. Moving forward. Okay, so again, this is another question that you all should not struggle with. So, it kind of takes a lot of work, but it's not a hard problem. So I know this is a little hard to read. This is, at least from the notes here that I'm using. However, your notes are not as blurry as mine. So the question states, which of the following are the initial and terminal points at the vector describing the same direction as v. So this, they're telling me is v, this vector. And I'm starting here, so this is my initial, and I move to this point over here. So this is the terminal point. Okay, now what I need here is the actual coordinate, because we're going to, I want to show you this way because it's going to show you, this is how we're going to look at these answer choices. Well, this is -2, -4, -6. These are going by 2's. And then in the up direction, it's going to be 2, 4, and this is kind of in the middle, 5. So it's -6, 5. This point over here is 2 in the positive, and again, these are going by 2, so -2 in the y direction. So these are my points. Now, what I want to do here is terminal minus initial. So it's going to be x2 minus x1 and y2 minus y1. So keeping the x with the x, the y with the y. Okay, so over here, this is my x2, my y2, this is my x1, my y1. So terminal minus initial. So this would be -6 minus 2, is just the x numbers, and then 5 minus the y1 is -2. So this ends up being -8, and these turn positive, so -8, 7. So as I start to look at these answer choices down here, I'm looking for the one that's -8 and 7. Okay, so let's start going through them. Again, I know these are a little blurry, but all of these, this is moving from this point to this one. So these are all the initial points. These are all the terminal points. So I'm going to do the same thing here. This is x2, so it's 4 minus -3. -10 minus -2. So these are minus, so these turn positive, these turn positive. 4 plus 3 is 7, -10, plus 2 is -8. So these are not the same, okay? Not the same as this one, so this, answer A, not the answer. Then I have to keep going. So now, look at this one. Again, this is -11 minus a -3 for the x, and 5 minus a -2 for the y. So these will turn positive, so this is going to be -8, and these will also turn positive. 5 plus 2 is 7, so this is now the same, -8, -8, 7, 7. That's my answer. Okay. So, moving on. So, this one has to deal with the magnitude now. Okay, so, I'm sorry. Let me go back to this one. These problems right here were like number 21 and 22 on your review. Okay, so you're just proving, are they the same or are they not? On this problem right here, this one's going to be like number 22 through 26. So, this is a problem where we have to work a little bit smart, guys, because if not, it's going to take us forever to get through. So, what I want you to see here, they're telling us that we're starting with a vector AB. So this is my initial, this is my terminal. And with AB, right up here, I'm going to do terminal minus initial. So this is going to be 8 minus a 4 and 5 minus 2. So this becomes 4 and 3. Now, what I found here is not the magnitude. That's what it's asking for. Which one has the same magnitude? So I'm going to find that now. Now that I have the components, magnitude is square root of x squared plus y squared, which is equal to square root of 4 squared plus 3 squared. I should put these in parentheses. So this is going to equal 16 plus 9, which means this is square root of 25, equals 5. So this is my magnitude right here. Now what I want to do is look at all of these answer choices. These are 4 different answer choices. Which one has a magnitude of 5? So work smart here, guys. Okay, I'm going to choose this one right here. This is answer R and answer T to start with. Okay, and the reason I'm going to do that is because the magnitude is very easy on those. This one's moving in the x direction, so it has an x component, but it doesn't move up and down. So this one's going to be 0 for the y component. So looking at R, it moved, again these are by 2's, 2, 4, 5 in the positive direction, so the component is 5 and 0 in the y. That means that the magnitude is 5 squared plus 0 squared, which is square root of 25, which is equal to 5. Well, this one and this one's the same, so answer R is my actual answer. Okay, so we got lucky there. But that won't always be the case. If I had to keep going, I'm going to go ahead and show you with W. Like, let's say this one wasn't the answer. Well, then I'd have to check the other answers. And so we can try to start with W here. This one is moving 2, 4, 5 in the negative direction, so negative 5. And then it moves 2, 4 in the y direction, so the magnitude of W would be negative 5 squared plus 4 squared, which is 25 plus 16, equals the square root of 41. So different. Square root of 41 doesn't equal it doesn't equal 5, so that's why W cannot be the answer. So last one's here. The polar equations, guys. So we went over 4 shapes for these. We went over the circle, the rose, the lemniscate, and the lemnicon. So you need to remember the clues for these. We'll start with the lemniscate. This one has R squared. Okay, and remember, lemniscates, they look like infinity signs. The lemnicon, they have either a plus or minus, and they kind of look like beans or something like that. The rose, there's a number in front of theta, and the circle, no number in front of theta. Okay. So looking at this right here, I can automatically tell, I'm just matching here, this is R squared, so I know that this is going to be a lemniscate. Okay. So what's also important here, so I have the lemniscates, the infinity signs, it's going to be one of these, either 13 or 14. Another thing you need to remember, when I see the word cosine, that means it touches this line here. Okay, so this must be a cosine equation because it touches this x-axis. You can talk about, you can say this one touches right here the cosine, the line, so this has to be cosine. This one right here, it touches that line, so this is a cosine equation. So since this one's a lemniscate and it's a cosine, this is the answer, 13. This one right here, number in front, no r squared, so this is a rows. And the only rows I have in here is 14. And this is cosine. You see how it touches the line here? So this is a cosine graph. This one has a minus sign, so guys, this is a lemma con. Again, cosine, it is touching that line, so this is a cosine. This one is number 11, and this is also a lemniscate because it is r squared. And this one is number 14. You see how this says sine? This one's not touching that line here, so I'm good there. Okay, so last thing here, the symmetries, guys. If I look at this one here, these are the symmetries I'm talking about. Pi over 2, polar, and the diagonal one. This one's called pole. So here, I do see that it does not look the same on both sides of this line. So it doesn't have pi over 2 symmetry. If I look at this line right here, yeah, it looks the same on both sides. So this one has polar symmetry. If I draw this diagonal, it does not look the same, so this one does not have pole. If I move on to this one, this does not look the same on both sides of that line, so it's not pi over 2. If I draw a line through here, yeah, it looks like it's the same on both sides, so this is polar symmetry. And the diagonal one here, it's not quite the same, so this one's not pole. If I look at this one looks the same, so it has pi over 2 symmetry. Here, it looks the same on both sides, so this one's polar. And if I draw a diagonal here, it's also the same, so this one is also pole. Okay, and last one here, not the same on both sides, so not pi over 2. It does not look the same on this one, so it's not polar, but through here it does, so it is pole. So this one's right here, guys. This is like questions number 27 through 32. So hopefully, if you were not here today, you're able to see this video, and also I hope you're in class tomorrow so that we can go over it and I can answer any questions you have. So that's all for this video. Look for the next ones.